We have successfully built a fantastic PCB using EasyEDA. But before we can send it for manufacturing, there are a few more steps to take. In this video, we'll see the steps for using DRC to identify and correct design errors and generate a Gerber file that can be used by any fabrication plant around the world. Design rule checking or DRC is an essential part of PCB development. If you have watched our KiCad videos, you will know that we have set up the design rules before we even started designing the PCB. However, EasyEDA is a bit different. Its default design rules are configured to suit many popular manufacturers. So if you have followed the generic design guidelines for most of your routing and placement, you should have very few to no errors while running the DRC. Let's see how many errors we encounter for this particular circuit. Go to the toolbar and click on DRC. EasyEDA will then check for any mistakes made during the PCB design process and display the results in the right pane. As you can see, no errors are currently shown up here for me, but that might not be the case for you. So let me first show where the design rules are set and why are they set that way. Then we'll look at how to fix those errors that we might face if we make changes to the design rules. To view the predefined design rule, go to the design drop-down on the toolbar and click on design rules. This will open up a pop-up with the default design rules and all the connections where these rules are applied. The values here might seem little arbitrary, but they are determined by PCB fabrication plant and their capability to produce PCBs. Since EasyEDA is owned by JLC PCB, we can check their capability list on their official site. First, let's look at the minimum trace width, which is 0.127 mm. If we cross-reference this with the EasyEDA, we have more clearance than required, that is 0.254 mm, which is excellent. Just because JLC PCB supports 0.127 mm doesn't mean every other manufacturer out there can handle the same clearance value. So it's better to set the clearance value a little higher than required. Similarly, if I compare the value for total clearance, wire diameter and wire drill diameter, everything stands at a good value and more than the minimum requirement, which is excellent. Now if we go back to the design rule, we have an option called track length. This isn't something defined by a fabrication house, rather it's a track length that we need to set for our tracks. Most of us won't be using these settings until and unless we start using impedance matching. So for now, let's not worry about this. So far, this default design rules have been applied to all the tracks on the circuit. But there might be a situation where you want different design rules for different tracks and connections. Luckily, we can do that as well. Just click on the add button here to create a new empty rule. Let's start by giving it a name. I'm going to call it power. So I can use this design rule for all the power tracks. Then let's set a minimum track width, clearance value, wire diameter and wire drill diameter. I know it seems like I'm rushing through all these design rules right now, but don't worry. We have a dedicated video related to design rules in our KiCad series. So make sure to watch that video. Even though it might not be related to EasyEDA directly, all the design rules and application will remain the same. We have added a new design rule called power, but this rule hasn't been applied to any of our connections yet. To apply this rule to the connection, go to the scroll window and select the connection name that you'd like to change. Since I named it power, let me use the VCC connection as an example of how to apply this rule. Here under set rule dropdown, select power and hit apply. This will apply the power rule to the VCC connections. I hope this video has helped you understand the design rules and how to create custom ones for your PCB within EasyEDA. So if you think the video was worth watching so long, please make sure you give it a sub. Anyway, now to test this new rule, simply click on settings and run the DRC. You'll notice a lot of errors popping up just by adding a single additional rule. Fixing these errors without disrupting the layout or routing can be challenging. So for now, I'll remove this additional design rule as our circuit is very simple and we don't have to make it complicated with this additional rule. However, I'll still show you how to fix the errors that can occur during DRC. I'll keep the changes I made to the default design rule and hit the settings button at the bottom. Now when I run the DRC again, we have a few errors. Two of them are related to the spacing between the track and the pad, and the other one is related to track and a wire. And the best part is EasyEDA shows the minimum spacing that it should be and what is the current spacing, so you can fix them. Just for demonstration purpose, instead of rerouting or adjusting the track, I'll simply reduce the track width from 0.5 mm to 0.3 mm and you can see the error is automatically fixed. Now let me do that for other tracks as well. One important thing to remember when reworking tracks that already have a copper pore is that you need to rebuild the copper area after each change you make. So the copper pore is updated with the latest changes. Now, after tinkering with it for a while, I was able to eliminate all the errors, which makes our board ready for manufacturing. The best part about using EasyEDA is how easy it is to place an order for manufacturing your design. Just click on the Gerber fabrication icon. This not only allows you to generate a Gerber file, but also gives you a cost estimation for manufacturing your PCB. You can play around with this and see how changing the color of your solder mask, quantity of PCBs affects the cost. But let's say not everybody wants to manufacture their PCB from JLC PCB. In that case, you can just click on Generate Gerber and it will download a Gerber file which you can send for other manufacturers. And this brings us to the end of the video. If you enjoy content like this about PCBs, make sure to subscribe to our channel. And if you have any questions or doubts related to PCB, drop them in our PCB Cupid Q&A section. Until then, keep learning and keep creating.